In this video, we're going to talk about applications involving percentages and ratio and proportions. And I actually see a little error here. In the title of this section here, we have ration. It should actually be ratio and proportion. So that should not be an in there. But in any account, we've already discussed what a percent is. It's how much out of 100. And it gives us a way to kind of standardize what we think when we characterize something. All right. And what I want to talk about now is actually using percentages to help us calculate things because they are so useful in so many places in life. The main use that we're going to get out of percentages is for us to be able to use the basic percent equation. All right. And the basic percent equation basically states that the amount is a percentage of the base. And there are three keywords in this sentence: amount, percentage, and base. All right. And so if I were to kind of change that into an algebraic statement or a mathematical statement, I could write it as amount equals percent times base. All right. One thing that I always remember is that the percentage is always going to be given to us using the percent symbol or either the word percent, and the base always follows the word of. All right. That's how much out of something that you're going to be using. That's your base. All right. And so what I want to do is I want to first just look at a generic problem looking at the basic percent equation. For instance, I have two examples here. Let's start with example A. It says, what is 22% of 70? All right. The goal of being able to figure that out is basically to just be able to use this percent equation here. Right. Notice that I get my percent here, and before I continue, I'm going to abbreviate this sentence here, or this percent equation, as A equals P times B. Percent times base, right? Amount equals percent times base. And so what we're given in this problem here is our percent is 22. And since this 70 follows the word of, as I stated here, then my base would be 70. And so what we're trying to find is A. We don't know A. And so if I put these things into my equation up here that I just wrote, I'm going to get the equation that A, which I don't know, that's what I'm trying to find, equals my percent. Now, when I put my percent and do any calculations with percents, I always have to change it to either a decimal or a fraction. And so I'm going to change 22% to a decimal. That'll be 0.22. And my base is 70. And so if I want to find 22% of 70, all I actually have to do is multiply 0.22 by 70. And what I'm actually going to get is that 22% of 70 is 15.4. All right. And so that would be my amount, and that would be my solution. So 15.4 is 22% of 70. All right. Let's go to part B. It says 84 is what percent of 175, right? Well, I see my base once again. It follows the word of. I'm trying to find my percent, right? So my P, I don't know. And so that means that 84 is my amount. And so what I'm going to do is I'm going to set it up just as in this equation here. A equals P times B. So I get 84 equals, well, my percent is going to stay P and my base is 175. I'm going to write this as 175P. That way I can solve for P by dividing both sides by 175. Once I divide both sides by 175, I'm just going to go ahead and put it in my calculator and do that division. And I get that P is 0.48. Of course, that represents a percent. And so I'm going to go change this from a decimal to a percent by moving my decimal two places to the right. So it's actually equal to 48%. All right. So 84 is 48% of 175. So that would be my solution there. All right. Let's look at a real world problem where we actually use percents. And the real world problems that we're going to get to are going to involve what we call percent increase and percent decrease. All right. A percent increase or decrease is a measure of how much a quantity has increased or decreased from its original value. So what percentage did this thing increase or did this thing decrease? You know, when you buy a painting, you buy certain things in life, you know, sometimes if they're valuable, they will increase in value over time. Whereas some other things, like if you buy a car or something like that, they're going to decrease in value over time. All right. And so by looking at percent increase, decrease, we can kind of come up with how we can determine that actual value that they'll increase or decrease by. All right. We're still going to use the same equation, that same basic percent equation that we were using before. A equals P times B. All right. We're still going to be using that. But the difference here is that our amount is going to be the amount of increase or decrease, right? That's the amount of increase or decrease in value of the certain thing. And then our base is going to be our original value. Let's look at an example where we kind of illustrate this situation. It says Nora bought a painting for $3,500. In 1 year, it increased in value by 18%. What was the amount of increase? And then what was the value of the painting after 1 year? All right. So what we're given in this problem here is $3,500. That is our base. Okay. We're given the amount of the percent increase right here. And so that's our percent. And so if we want to know the amount of increase, right, then all we have to put is our percent in for P and our base in for B. And then we'll have our amount. So if I do that, I'm going to get A equals, my percent changed to a decimal is 0.18, and my base is 3,500. All right. And so when you figure out what 0.18 times 3,500 is, you'll see that it is actually $630. And so the amount of increase would be $630. All right. Now I'm ready to go to the last part of that problem, which says, what was the value of the painting after 1 year? Well, we just found that it increased in value by $630. And so the value after 1 year is going to be that same $3,500 that we started with, but we have to add on to that the amount that it increased by. Remember, increase means that it goes up. And we'll add those two together and we get $4,130. And so the amount the value that painting is worth after 1 year has increased to $4,130. All right, what we're going to talk about now is simple interest. All right, simple interest. And with simple interest, we use this formula, I equals P times R times T. All right, and so basically how simple interest works is you put some money in an account or a fund or a bond or something like that, and they'll tell you what type of interest you're going to get. And we're just going to assume that we're always going to be talking about simple interest in this course. And so you put the money in the account, and actually as the money is sitting there, your account is actually going to be growing, earning interest. All right. And the simplest type of interest is simple interest. That means you're just going to be earning money on the amount that you put in the account, not actually on the interest that you earn. All right. The formula for calculating simple interest is I equals P times R times T. I is your interest. All right. That's the amount of money you're going to be adding on to what you put in the account. P is your principal. That's the original amount that you put into the account. R is your interest rate, and that's pretty much always going to be given to you as a percent. And your T is for time, and that's pretty much always going to be in years, or you'll have to change it to be in terms of years. All right. And so I want to look at an example where we use this formula to help us calculate simple interest and help someone determine how much is going to be in their account after a certain amount of time. All right, in this example, it says a student invests $3,500 in a savings account at 6% simple interest. How much is in the account after 10 years? All right, to determine that, well, we've got to use our simple interest formula, right? I equals P times R times T. Before I determine how much is actually going to be in the account, I've got to calculate the interest first, right? Notice that this $3,500, that's going to be our P. That's how much they initially put into that account. This 6%, that's going to be our rate. And then that 10 is going to be our time, right? And so if I put those values into our formula, I get I equals 3,500 times, remember when we do a decimal, we got to change it, percent, we got to change it to a decimal or a fraction. It's a lot quicker to change it to a decimal. And then my time is 10. All right. And so if I multiply 3,500 by 0.06 times 10, I'm actually going to get $2,100. And so this is the amount of interest that that person has earned. That's how much their account grew by. That is not the amount of money that's going to be in the account. Because remember, they started with $3,500, right? And so if I want to know how much is going to be in an account after 10 years, then what I need to do is take that original amount, which is $3,500, and add to that the amount of interest that we've earned. And if I add those two amounts together, we get $5,600. And so that's the amount of money that's going to be in that account after 10 years. All right. What we're going to do now is we're going to go to ratio and proportion. All right. A ratio is a comparison of two quantities using division. All right. It's a ratio of two quantities using division. All right. And a lot of times we can actually write ratios as a fractions. Right. For instance, the ratio of 1 to 2, you might see it written with a colon between it, or 1 to 2. All right. Well, that actually is the same thing as 1 divided by 2, like 1/2. So it's like a fraction, basically. All right. Those are ratios, just comparing two numbers using division. All right. A proportion is a statement of equating two ratios, right? Setting two ratios equal to each other. For instance, 1/2 is exactly the same thing as the ratio 3/6, right? Because, if I simplify the 3/6, right? 3 goes into itself one time, it goes into 6 twice. You're going to end up with 1/2, right? And that's what I call a true proportion. It's an equation that equates two ratios. They may look different, but they're actually the exact same thing. And so what we want to do is we want to look at proportions where, hey, I might not give you every piece of the proportion. Maybe I won't give you this 3 right here, and I'll ask you to find the 3. All right. And I want you to be able to do that so that we can solve application problems that involve proportions. The tool that we're going to mainly use to help us do that is called cross multiplying. All right. Cross multiplying means I multiply across my equal sign, basically. I'm going to multiply the 2 by whatever's sitting up here. So this denominator gets multiplied by this numerator. And then I multiply my denominator here by the opposite numerator. Once I cross multiply, I'll no longer have any fractions, and so I'll have an equation without fractions, which is easier to solve, and that'll allow me to solve the equation more simply. All right, let's look at an example where we do this. All right, this one says to solve the proportion 18/40 equals n/180. All right, and so what I'm going to do is I'm going to use that technique of cross multiplying. All right, I'm going to multiply the 18 times the 180, and I'm going to write it here before I do my calculation. And I'm going to multiply the 40 by the n. That'll give me 40n. All right, 18 times 180 is 3,240. And then 40n is just 40n. All right, and in order for me to solve for n, I've got to divide both sides by 40. And so when I divide both sides by 40, I'm going to end up with n equaling 81. Okay, so 81 is that number that'll make this a true proportion. It'll make it a true proportion, and so that is what we have there. All right, and this concludes our video on applications of percentages and ratios and proportions.